some series to integral calculus. Some series to integral calculus into which we are pursuing the discussion, and we are trying to calculate summation series of an alternative number. Okay, we will see other way of alternative number means 1 by alternative number. 1 by right now the alternative number that we are taking right now, it is 1 4 3 6. Up. 1 4 3 6 5 8 7 and so on. What is alternative? Alternative means alternate odd and even number will come. Alternate, okay, means if I have 1 as an odd number, the next will be even number 4, then odd number 3, then even number 6, 2 gap, then odd number 5, then even number 8. So there are two series in it actually. At the odd places we have 1 3 5 7 9 11 and so on. At even places we have 4 6 8 10 and so on. Makes sense? Means there are, okay, what I'm trying to say is that there are, if this is x axis, then x equal to 0, x equal to 1 2 3 4 5 6 7 8, and at every x we have function over x. This is function over x, vertical y axis, this is y axis, and this is x axis, x equal to 0, x equal to 1 2 3 4 5 6 7 8 9 10 and so on. Okay, when x equal to 1 I have function over x is 1. When x equal to 2 I have function over x is 4. When x equal to 3 I have function over x is 3. When x equal to 4 I have function over x as 6. What I mean is, when x is odd number, x equal to 1 3 5 7, I have function over x as odd number only, 1 3 5 7. When x equal to even number, when x equal to even number, means x equal to 2 4 6 8 and so on. When x equal to even number, when x equal to 2, function over x is 4, x equal to 4 6, x equal to 6 8 and so on. So on the even slots the value is 4 6 8 10 12 and so on. When the x equal to odd number, the function over x is odd indexes, then 1 3 5 7 9. When it is even, then 4 6 8 10 and 12 and so on. Okay, what I'm trying to say, this is alternate series. Alternatively, we have different kind of stuff. One is, alternatively we have two series. One is odd series, 1 3 5 7 9 and so on. One is even series, that is 4 6 8 10 and so on. What is summation of this? This is what we are calculating, and in that manner we have used successive approximation and integral calculus. We will try reverse of it also, opposite, means 1 by 1, 1 by 4, 1 by 3, 1 by 6, 1 by 5, 1 by 8, 1 by 7. We'll try if time permits. Why it is like so? Because when we are taking two different series, then we will have two different kind of n. We will see now. And then if this series will go till infinite, 1 by 1 plus 1 by 4 plus 1 by 3 plus 1 by 5 plus 1 by 6 plus 1 by 7 plus 1 by 8, this will go up till infinity, because it will tend to 0. Whereas 1 4 3 6 5 8, it cannot go up till infinity, because it will be very high number. So we will have, now we, to solve it, we will segregate the odd slots, odd number of x, not function over x. If I have value 1 4 3 5 6, this is function over x, value at these slots. These slots are x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If these are the slots, then we will take first the odd number slots and then we will take even number slots. Odd number slots and even number slots. Odd number slots, we have slot number 1, 3, 5, 7, and we have function over x or value at these slots are 1, 3, 5, 7, and so on. For even number slots, we have 2, 4 slot number 2, 4, 6, 8, and so on. And function over x at these slots are 4, 6, 8, 4, 6, 8, 10, and so on. Okay, this is what it is. Now consider, now if I tackle the odd slots, then I have function over x, I have number as 1, 3, 5, 7 at slot number 1, 3, 5, 7. Means if I divide this into n different parts, each part will be x, just x. When x equal to x, I have function over x is x only, because slot number 1 value is 1, slot number 9 value is 9. Means we want summation x equal to 1 to n, x equal to 1 to x equal to n, sigma sign x equal to 1 to x equal to n, function over x. Okay, it's not n terms, x equal to 1 to n, where n will proceed every two, x is 1, x is 3, x is 5, and then x is n. Okay, function over x means function over x plus function over x plus function over x, and then function over x, where x is 1, 2, sorry, 1, 3, 5, 7, and 9. Makes sense? Now we are taking these many examples so that it will be crystal clear to anyone, because this is a new concept and not available in any of the books. If that is the way, then when function over, now we are trying to calculate 1, 3, 5, 7, 9 addition. Okay, now function over x, if I take as x, it is a discrete function. When x equal to 1, I have 1. X equal to 3, I have 3. X equal to 5, I have 5. If I connect all the top points, then it will result into one curve, and that curve is function over x, that is x. That is a straight line actually. Okay, it is not a curved line, it is a straight line. Okay, x, because when x is x, the height is x. Okay, now we have another function called gx, and it is a continuous function. Fx equal to x is a discrete function, and it is defined only at x equal to 1, 3, 5, 7, and so on. 1, 3, 5, 7, and so on. When x equal to fx, then I have this is a continuous function. When fx equal to x when it is a continuous function, fx sorry. Okay, consider a continuous function as gx. This is a continuous function gx. This is a discrete function fx equal to x. Gx equal to, I don't. We are using integral calculus to calculate the summation of 1, 3, 5, 7. To have the integral calculus working, we need to have area calculation. To calculate the area, we need to have continuous line. Consider gx is a continuous line, and gx from x1 to x2, gx dx integration limit x1 to x2 is the area under gx from x1 to x2, area under the gx. Okay, if this is the area under the dx from x1 to x2, this is dx x1 to x2. Okay, if that is the scenario, dx x1 to x2, if this is the area under the dx, can I divide this area into different sections? First section, second section, third section, fourth section, and so on. What do you mean? I'm dividing, and gx is a fictitious continuous line that I don't know what is gx. And since this is a fictitious continuous line between x equal to x1 and x equal to x2, there is an area between it, that is gx dx limit x equal to x1 to x2. This area can I divide into equal number of parts the way I have the fx verticals. Fx vertical is at x equal to 1, x equal to 3, x equal to 5, x equal to n, can I divide gx into n different area section, where first area section is gx, first area section is between x equal to 1 and 3. Next is 3 and 5. Next is 5 and 7. And last one is n to n plus 2, because gap is 2 everywhere. N to n plus 2. Means, can I have a gx dx where it starts from x equal to 1 and it goes till n plus 2? And then I divide it into various area section, where first area section is from 1 to 3, 3 to 5, and last is from n to n plus 2. Means each area section is exactly same as the height of the fx on left hand side, x equal to 1, x equal to 3. Means if I have a fx, if I have a fx, this is a straight line. If I have a fx at x equal to 3, if I have a fx at x equal to 3, then this fx is exactly same as area between x equal to 3 and 5, gx dx. Gx dx, area between 3 and 5, whatever the area is, that area is same as fx at x equal to 3. Means whatever the vertical we are trying to add through summation series, it is same as the addition of all the sub area on right hand side of the vertical, and that spans for two units. This we have already done in the last session. This time we will try left hand side. Left hand side means if I have a fx is a straight line. Okay, how I can show? Consider this is fx and this is a straight line. If this is fx and this is a straight line, where x equal to 1, I have fx as 1. Consider there is an area from x equal to 1 to x minus 1 minus 2, that is minus 1. Minus 1 to 1, I have an area strip, and that will go and hit gx. X equal to 1 to 3, I have an area strip, and that will go and hit gx. 3 to 5, I have an area strip, and it will go and hit gx. There will be equal number of area strip the way we have verticals. X equal to 1, 3, 5, 7, n. There are, I believe, 2n minus 1, sorry, n by 2 minus 1. I mean, some verticals are there. Accordingly, we have sub area on the left hand side of width 2. What I'm trying to say is that if I say x equal to 1 to n, fx equal to x summation sigma summation x equal to 1 to x equal to n function over x, means function over x, function over x, function over x, function over x, where x is 1 3 5 7 up to n. It is same as limit x equal to 1 minus 2 to 1 minus 2 to 1 gx dx plus 1 to 3 gx dx plus 3 to 5 gx dx. Same number will be there. The way we have verticals at x equal to 1, 3, 5, 7 fx, same we have for one fx, we have gx dx, area of them. Okay, the last one will be limit n minus 2 to n gx dx. Makes sense? Now for any x, and at any x equal to x, at any x equal to x, fx is 1. Fx is x. We have fx at x equal to x, that is x. X equal to limit x equal to x minus 2 to x gx dx. Means if I take fx, if I take okay, if I take fx, okay, if I take fx like this, then at any x I have fx as x, and that will be same as x to x minus 2 gx dx. Okay, that will be same as x minus 2 to x gx dx will be same as fx at x equal to x, means x fx at x equal to x is x only. X equal to x minus 2 to x gx dx. I have to find gx. I have to find gx in this manner. Okay, that is the question mark now, and we will try. Okay, fx equal to gx dx, gx equal to dfx by dx, that is 1. We'll try gx with 1. 1 dx will be x, x minus 2 to x will be x minus x 2. We are getting 2, wanted is 1, means whatever we had tried I have to multiply it with by x by 2. So we had started with 1, we will try with x by 2. X by 2 integration is x square by 4, x minus 2 to x. Okay, that will become x square minus x minus 2 whole square. That will become x square minus x square, that will go away. 2x minus 1. X minus 1 whole square will be 2 minus 2x plus 1. Outside minus is waiting. 2x minus 1 by 4. By 4. We had taken x by 2. X square by 4. Okay. Hope. I think we have done some mistake. X square by 4. X square limit is x minus 2 to x. X square minus x minus 2 whole square. X square minus x square plus x minus 2 whole square is x square minus 4x plus 4. Minus is waiting outside. X square will go away and it will come as 4x. 4x minus 4. 4x minus 4. Okay, by 4. X minus 1. Waiting outside fx is x, we are getting x minus 1. We'll try with plus 1. Plus 1 means integration will be x. X minus 2 to x will be 2. We want 1. So we will try with x 1 minus 2. Okay, so we will try gx as x by 2 plus 1 by 2. Okay, I believe then it will come as same x by 2 plus 1 by 2. X by 2 integration is x square by 4. And then x square by 4, x square limit x minus 2 to x will come as 4x minus 4 by 4, x minus 1 plus 1 by 2 integration will be x, x minus 2, that will come as 2, 2 by 2, 1, 1 will go away and it will be x. Hope. This is what we wanted, x. Okay, we got it. Gx is x by 2 plus 1 by 2 and 1 by 2, and actually we get as x. Okay, what do you mean? If I am getting gx x by 2 plus 1 by 2, if I integrate from minus 1, okay, the first integration is from x is 1, then 1 minus 2, that is minus 1. Minus 1 to 1, if I integrate, then it will come as 1. Yeah, certainly. Try. Limit x equal to 1 minus 2, that is minus 1 to 1. Dx will be 1, that is the vertical value. Anyone can try. Okay, x by 2 plus 1 by 2, x square by 2 plus 1 by 2, x minus 1 to 1. 1 square minus 1 square, that is 0, gone, plus 1 by 2x, 1 minus 1, 2 by 2, 1 only. You mean if I integrate from x equal to 1 to 3, then right hand side it will be 3. Yeah, it will be 3. That is 1 to 3, x by 2 plus 1 by 2 x dx, x square by 2 plus x square by 4 plus x by 2. 1 to 3, that will come as 9 square, 3 square minus 1 square, that will come as 8. It will come as 8 by 4. 8 by 4, that will come as 2. And then x by 2, x is 3 minus 1, that will come as 2. 2 by 2 is 1. Okay, this side 2, 2 plus 1, 3 only. Okay, someone can try. If I try for x equal to 3 to 5, it will come as 5. Means we have got a gx for which if I calculate the area from lowest limit to highest limit, I get the sum and summation. We will try now. The final is from x equal to 1 minus 2. It is minus 1 till n. So integration x equal to minus 1 to n gx dx will give the summation of the 1 plus 3 plus 5. This is little different than the last one. We tried right hand side area. This side we trying left hand side area. Gx dx If I try, it is x by 2 plus 1 by 2, 2. X square by 4 plus x by 2. X square by 4 plus x by 2. If that is the case, then it is going from x equal to minus 1 to n. X equal to minus 1 to n. If that is the case, then what it will be? It will be n square by 4. And then we have minus 1. Minus 1 whole square. That will be minus 1. Minus 1. That it will be n square minus 1 by 4. Makes sense? N square minus 1 by 4 plus 1 by 2, that will be 1 by 2x, n minus minus 1, n plus 1. Makes sense? N square minus 1 by 4 plus n plus 1 by 2, 2n plus 2 by 4, n square minus 1 plus 2n plus 2n plus 2. That will come at n square plus 2n plus 1 by 4. N plus 1 whole square by 4. N plus 1 by 2 whole square. This is what we had got last time also. Means perfect. The addition of all the odd number 1, 3, 5, 7 is indeed n in n plus 1 by 2 whole square. Okay, we will try both for the even number slots. Even number slots starts from 2 and again gap is 2 to only. Okay, and it will go up till n, where n is even number. N slot number n on x-axis is even number. What we tried last was the odd number. If I try with the even number, then how it will be? Fx equal to limit x minus 2 to x gx dx. Same thing, but fx will be different now. Earlier fx was x. Now fx is x plus 2. When x is 2, the value is 4. When x is 4, value is 6. When x is n, then value is n plus 2. So it is x plus 2. X plus 2 equal to limit x minus 2 to x gx dx. Let's start gx with 1, the way we had done. X minus 2. Here it is 2, and here it is x plus 2. Means more or less x is not there. So we will start with x dx, x square by 2. X square by 2, x square limit is x minus 1, 2 to x. Then it will be x square minus x square. Gone away. 4x minus 4 by 2. 2x is coming. Here it is coming 2x and here it is x. Means we have to divide by 2. We started with x, we will start with x by 2. Same thing, x by 2. X square by 4. X square, and from x minus 2 to x will be 4x minus 4 by 4. X minus 1. Here we have x plus 2. Here we have x minus 1. Means we want 3 more. 3 more. So we will try with x minus 1, 3 more. Means we have to try. I'll try now x by, we started with x by 2. X by 2 plus 3 by 2. This is what our experience is. 3 by 2. This will start. Dx equal to x by 2 plus 3 by 2. X by 2, if I integrate x square by 4, x minus 2 to x, it will come as 4x minus 1. 4x minus 4 by 4. X minus 1. 3 by 2, x minus 2 to x, that will come as 2. 2 to gone plus 3. X minus 1 plus 3 is x plus 2 only. Perfectly alright. So gx we can take as x by 2 plus 3 by 2. Someone can try. If I the first integration, first x is x equal to 2. First integration will be from x minus x equal to 0 to 2. We'll start x equal to 0 to 2. Dx it should be 4 because first vertical is 4. Okay, amazingly, we'll try x by 2 plus 3 by 2 dx. X by 2, x square by 4 plus 3 by 2x. Now limit will be 0 to 2. X square by 4 will be 1. 0 to 2 it will be 1, and 3 by 2, 3 by 2. x limit is 0 to 2, that will come as 3. 3 plus 1, 4 only. Mind blowing, amazing. We'll try next one, that is x equal to 2 to 4, and then it should come as 6. 2 to 4, it should come as 6. 2 to 4, x by 2 plus 3 by 2. X by 2, x square by 4. And then limit is 2 to 4. 4 is 16 and 2 is 4. 16 minus 4 will come as 12. 12 by 4 will come as 3. 3 by 2 x. X is 4, 2. That is 2. 2, 3. 3. And first we had got 3. 3 plus 3 is 6. Amazing. So we have got now gx for the even number also. X by 2 plus 3 by 2. Now limit, if I calculate for the full summation, that is 4 plus 6 plus 8 and so on, then it will be x will start at 2, 2 minus 2, 0. 0 to n, where n is even slot. 0 to n and x by 2 plus 3 by 2 dx. X square by 4 plus 3 by 2x. 0 to n, it will be n square by 2, n square by 4 plus 3 by 2 n. Now we have to merge both so that we get the final summation of this series. So final summation, left side we have n square plus 2n plus 1 by 4, and this side I forgot. Okay, this side we have n square by 4, n square by 4 plus 3 by 2n. Yeah, this is what it is. N square by 4 plus 3 by 2 n. N square plus 6n by 4. I think this is what we had got last time also. N square plus 6n by 4. This side n square plus 2n plus 1 by 4. Can these two n be same? Not. This is odd number n and this is even number n. Now I have to see what is the actual question in examination. Actual question in examination is 1 plus 4 plus 3 plus 6 plus 5 plus 8 plus 7 plus 10 plus 9 and so on up to 124, which last number is 124, that belongs to slot number 122, and that is even number. So n as even we will take as reference, and n in odd number we will take 1 minus. So n plus 1, n plus 1 by 2 whole square will become n minus 1 plus 1, because n is coming from even number. That will become n square by 4 plus n square up again I forgot. This side we had, I remember, n square by 4 plus 3 by 2 n. Okay, n square plus 6n by 4. So it will become n square plus 6n by 4. 2n square plus 6n by 4. This is what exactly we had got. If I say I have to compute this summation, up till 123. So 123 is the last number that is odd. So prior to that, it will be 124. I think so. 1 and then 4 and then 3. If last is 123, previous will be one more than that, 124. But 124. But last number is 123, and previous to that is 124. But slot number is 122 and 123. Means slot number of odd number is more. So even number I will take n as n minus 1. N square plus 6n will become n minus 1 whole square plus 6n minus 1 by 4. This n will return n square plus 2n plus 1 by 4, and then we can add and we can have the result. Someone can try. Okay, I can try. Consider I want to add 1, 4 and 3. Means last slot is n equal to 3.